All right, hi everyone. Welcome to the Docker Singularity tutorial. This hopefully will not be a false start. To start out, I just want to walk through some questions as to why one would even want to use Docker before I really go into like what it is and everything. So I'm going to throw out a couple scenarios, some of which you guys have already just heard. But how many of you guys do work on a research project, put it down, and then pick it up, say like 6 months or a long period of time down the line? So that can relate to a lot of people. So Docker will be a solution to help out with that. How many people work on multiple projects at a time that might have different requirements, such that Project A requires a certain version of the software, maybe Project B requires a slightly different version because you're working with a collaborator or someone else that puts on these external requirements on you. Docker is a solution to help out with that. If you ever have been in a journal club where they walk through the paper's methods and you disagree with a small portion of what they did, but you really have no way of testing to see if your criticism actually impacted the results. If the paper released their data and code, and if they use Docker, then you would have a way to actually test your hypothesis and saying whether or not that particular analysis choice made a difference. So it'll help by, I think Docker is a solution to help with communication in science more accessible and more meaningful through sharing your code and software environment. So with that said, we can start going through what container-based environments are and step a little bit into the weeds, but I'll try to keep it as cursory as we can. So they give some scenarios in research that might be a little bit more tooled towards the person that's always making software for scientists and stuff like that. So a slightly different audience than what we are going for, but they go through, but this also applies to many scientific scenarios as well. So computational environments can be difficult to create. So that means if you have to install Python and R and all these other software packages, it can be difficult to set up on your computer. And then imagine the case in which you now have a trainee in which you need to get up to speed. And now you have to go through all of that pain again to get all the same versions of the stuff that you have running on your computer on their computer. So again, Docker is a solution to help out with that. So they'll define a container as a standardized unit of software that can run anywhere. Yes, anywhere as long as you know enough about how to run it. But we already went through the difficult part of actually getting Docker installed, and I want to say for most people, it won't be that painful of a process. So getting Docker installed, once you do that, it opens the doors for being able to install other things a lot easier. So they say, what do containers provide? They provide a standard method of creating and sharing computational environments. So that's this idea of using that recipe file that I mentioned offline, where you specify instructions for install this, install that, and build a Docker image with that. And then sharing computational environments, we'll primarily do that through Docker Hub in our case. So Docker Hub is I guess for those that know GitHub, Docker Hub is the is the GitHub for software environments as opposed to just code. And then it provides isolation of computational environments. So by that we mean when you make one Docker image, it's going to be completely isolated and independent of another Docker image, such that you can have like all the different versions. You can have several different versions of software installed on one than the other, and they won't conflict with each other. And then easy interoperability. As we can see, we have the full spread in this room, where it's Windows, Mac, and Linux for me running Docker. So we can run Docker on any operating system. And then immutability of environments. You cannot permanently alter a container unintentionally. So that's the idea. If you started a container and you're running inside interactively and you install something else while the container is running, unless if you specify a particular option, when you log out of that container and that container shuts down, all the changes you made are lost inside that container. So only the changes that are, only the software that's specified in that recipe file stays installed in that container. And this will come up when we, if we get to talk about how do we build up like a recipe file for making a Docker image. A lot of times people start out with the closest thing to what they want that's already available. And then you start installing things while you're interactively logged in to see what are the necessary commands to install the software. And then you literally copy paste from that the commands that you ran from the terminal into like this recipe file. And then the recipe file will be able to build it consistently every single time. So that will be we might be able to cover that today, but if not, you heard at least the outline. So why do we need containers? We've covered this a bit already. They say science reproducibility. Each project in the lab depends on complex software environments, which, they include Python, MATLAB, and R. This is becoming, and then the operating system and particular drivers for the operating system. So it becomes a real big chore to have someone that can keep track and maintain of where everything's installed and how everything's installed. So as long as you use a recipe file for a Docker image, people can read up on what was actually installed on that container and be able to trace it back to exactly how to make it. And the short-term perspective, they talk about collaboration with your colleagues. So we already touched on this. And changing hardware. I didn't quite cover this. This will be related to the, so they mentioned the notion of changing your laptop. Once your laptop gets old, you might switch hardware. And Docker makes it easier to just be able to pull in that image even though you're operating on a different laptop. So maybe you're doing some development at home on your laptop, you go to work on your work machine, you can still pull the same Docker image and start and pick up where you left off for the most part. And then also, if you're dealing with high performance computing clusters and you need more power than is available on your laptop to really chug through your data, then that's where Singularity will come in. But you can build up your Docker image and make sure it works on your simple case before you scale up and start using it on these large data sets. Oop, I don't know what happened there. Freedom to experiment. And this is also what I really like about containers too, is trying to as a teaching tool as well. because it allows you to essentially break and like try to smash things as much as you can within this container. Because as I said, as soon as you close that container, all the changes that you made are knocked off by default. So you can log in, spin up a Docker container, do a bunch of work inside it, delete like important files on accident or on purpose, doesn't matter. And then log out of the container or otherwise exit the container, and you'll be safe and good to go. So it really allows you freedom to experiment and change things without in a low stakes environment. Because if you do this on just on your regular laptop, if you delete like System 32 or System 64 on Windows, then you won't be you'll be in for a bad time. And then, yeah, and if you try to remove anything in the root directory in Linux or Mac, then you might run into some issues. Yeah, and then using existing environments. So installing all dependencies is not always easy. So this is why we're interacting with a container to be able to test out those commands and be able to break things as we try to install things, and be able to step out and step back in without having like your computer in a, I guess, kind of a brick state. So this helps get around that. So yeah, if you're running a container on your laptop, it uses the same hardware. So it's communicating with the hardware in your laptop. But what it says by user spaces and libraries, it means, as far as I understand it, that your any permissions, or like who owns files and who is registered as like a user on your computer, is different. And the libraries, which is essentially all the again, as far as I understand it, like all the software that comes in with the operating system, those are all independent of your host machine or whatever machine that you're running Docker on. So these are the illustrations that they have to showing like a little mini computer on your host computer. So that's the analogy to take away here, is that we're essentially spinning up little mini computers on our original computer. And then you can create bindings between your mini computer and your host computer. So this is useful for when you wanted to, well, we're going to cover in the tutorial today. This is if you wanted to have the software environment, but you want to work on some new data, or you want to save some changes to data that you're working on. This allows for communication between the mini computer and your host computer, so you can output useful results. Tools. So they've been mostly staying agnostic towards about what container you're talking about. I've been talking about Docker, but they talk about virtual machines and containers. So with virtual machines, those are kind of running another operating system on top of your operating system, such that it's a little bit. The takeaway is that virtual machines are just a little bit heavier than Docker or other or Singularity. They just take a little bit more. They take a little bit more oomph to run and to boot up. And Docker and Singularity are more lightweight and share more with your actual computer, as opposed to virtual machines, which don't really share much with your original hardware. They kind of have to communicate through an intermediary in order to communicate with your host machine. So this is the illustration that they have for that, where they show those that guest OS being the kind of the additional layer for those virtual machines on the left there. And they have we're not going to talk about the difference between a hypervisor and a Docker engine, but I'll just say that that's there. Yeah, we're just going to skip this. Like I said, we're going to try to keep this a little bit cursory. If you want to have additional questions at the end, we can cover those. So yeah, Docker might be the most portable technology right now, but if you use HPC centers, you will probably have to use Singularity instead. And that was when I mentioned earlier before the recording about you need administrative privileges in order to run Docker, but you don't need administrative privileges to run Singularity. Yeah, and then that's how to install it. And then we are going to skip this. And that is the end of the tutorial. I mean, of the speaking portion of the tutorial, or at least the only speaking. Now you guys are going to be doing things. I'm still going to be talking. So the first thing, if I can scroll down here to the Readme, if you all can click on your Docker quick start, or just like your, or just open up your terminal, so you have access to your terminal, and you all have run Docker run hello world, right? If not, we can. I'm just gonna be in here for now. So remove that. Okay. So I'm gonna type Docker run hello world. So it should, when we see unable to find image hello world latest locally, what Docker does automatically when you try to run something, it looks up on Docker Hub where that image should be if you don't have it downloaded. So even kind of going beyond dealing with installation, Docker can also take care of actual downloading of things for you as well. So what happened here, it was pretty unremarkable. I just printed some stuff out to the screen. We're going to try to do something that can hopefully provide a little bit more utility to you as a user of Docker in order to give you something cool to work with. And that's going to be for anyone that's on Linux or has Docker Desktop installed. You can run this line. But if you have Docker Toolbox, you'll have to run this line. And the change is that the URL is different here. Because in the Docker Desktop version, the Docker installation is more communicating directly with your host machine. But for the Docker Toolbox, it's kind of communicating through your through the virtual box or through the virtual machine. So if I run this, for me, it might not say I found it locally, but it should find this locally, and then it should just run it for me. For others that ran it, it should say cannot find this image locally, and then it should start downloading things. Is that the case for everyone? Or what type of errors are we getting?
Unauthorized input username and password.
Sometimes you might need to type sudo docker to run.
Okay.
So just take that same command and add sudo to the beginning of it. And I think that might be true for the Macs.
Yeah, and I'm not in it's probably not gonna work anyways.
Are you on a terminal on your local computer?
Mm-hmm.
So
SSH into
no, I mean, do you have administrative privileges on your host computer? On the computer that you're using on that Mac?
Not on the account. So I could either switch accounts or I could SSH into. No, that wouldn't make. That doesn't work if I SSH into another computer. That doesn't work. So you can use. Yeah, you wouldn't want to. Can you use there's a command that's called su. Then that allows you to log in as another user within your terminal.
So what was then you type in the name of the account that you can log into.
Thanks.
I'm not getting it either.
What is yours saying?
Usage docker run options image command. I don't know.
So does your command look exactly like this?
No. That might be why. Is there a reason it's not pasting?
I guess the question was is that the command wasn't running, it was presenting usage information, and now the question is why isn't copy paste working?
Yeah.
And now the reason for copy paste can be for a variety of reasons. There are different rules on different operating systems for how copy paste functions on your terminal screen. For Git Bash, I believe it's Control Shift Insert. Do you have an insert button on your keyboard?
Yes.
So if you hit Control Shift Insert, then it should paste inside your Git Bash terminal for Windows.
Manually pasted it,
Okay.
And it's going.
Okay, it's going now. All right. So does everyone's look like this now, or is it still downloading? Still downloading.
I'm restarting my computer.
Okay.
No, I gave this account admin privileges, and therefore you have to restart the computer.
Okay. For the interest of time and for I guess the potential internet viewers, I might move on to the next step, but we can come back to it and then we can like cut the video short in case like we cover all the main things and can come back to doing other things. All right. So now what happened in here isn't very remarkable. What we just saw is like, oh, okay, we just saw some type of service start, and that it just is now I don't have access to use my terminal anymore. In fact, this looks like less than good because now I can't type anything in the terminal. But now what we can do is using the same URL that we specified here, or the same IP address that we specified here, which again will be different between Docker Desktop and Docker Toolbox. We can copy paste this information into our favorite browser, hit enter, and now you should be able to see this. What do people see?
I see that.
You see that? All right, we got one. You're restarting. And then with yours was the Docker Toolbox. Did it not work?
No.
It's downloading.
Oh, it's still downloading. Is yours still downloading, Maria?
No, it's downloaded. Let me repaste. Just in my search bar, paste the URL.
Yeah. So it'll be for Docker Desktop, it'll be 127.0.0.1:8787.
Add an extra 8787. There, I got it.
All right. So now you should have this will probably be blank for you, but the username will be RStudio. And the password, we actually specified it here ourselves. Call it the UIBH, UIO Brainhack. So username RStudio, UIBH. I can sign in. Sure, I'll update the password. Doesn't mean anything. And now we are working within our Docker container. So what we have here is a full installation of RStudio that you didn't have to go through a URL to, you didn't have to go through the installation process of going to the RStudio website, downloading RStudio, and downloading say certain packages that you wanted to work with RStudio. Now you just have installation of RStudio that within this project directory, we can open up a notebook folder. And right now I just have some of the commands that were copied from the R lesson. So we can just go through and read in the data that's stored on this Docker container. And everything will run exactly as we would expect for RStudio to run.
So are the data stored on this, or are they on your computer?
So right now the data are stored on the Docker container. So when I exit and when I leave this Docker container, if I made any changes to the data, that will be erased. But I will cover with our next command how we can bring in the data and have the changes to the data be persistent, and even to our code files if we want to change those. Because primarily what we want to keep consistent here is just the packages that we have installed on RStudio. All right. So do we have any questions so far about this? I guess. So the people that have been able to get it to run, which is one half of you got it. Did you get it to run?
No, it's still installing.
Oh, it's still installing. Okay, but maybe in theory that it'll eventually work.
I have one question.
Yeah.
You here, what happens in RStudio? We usually download the softwares and give the paths, and we do like that. But here you don't have to do any installation. How you map it to the main software in the machine, the Docker? How they? I mean.
How are they communicating?
I mean, I would say the Python 2.7, 3, how does it interact or something? Is there anything you're going to do?
Yeah, so the question is, so if I wanted to, could I send commands from my host machine to this Docker container, like programmatically? Or is that the question?
No. The question is like how multiple softwares you can deal with in this Docker, like in your multiple Dockers?
Yeah, you can make as many Docker images as you need. I could have a Docker image that has Python 2.7 installed. I can have a Docker image that has 3.5, 3.6, 3.7. You'll have as much space as there is space on your computer to store all these different Docker images. And what's nice as a side note about Docker is if there are similar layers in the Docker images. It's like if you have like 10 Docker images, but they all are running, say Windows 10 Home, then that layer for Windows 10 Home will be the same for all Docker images. So it'll only take up the space as it would take to just have one Windows 10 Home operating system for those 10 Docker images. So it is space saving in that sense. So yeah, but you can have as many different software versions as you need for your purposes for spinning up Docker images, as long as you have enough hard drive space.
So did this come from your, like whatever we just downloaded to our container?
To your, you can just say to your host machine.
Okay. Did that come from your Docker hub? Or
so the question was, where did this Docker image that we are running come from? And it came from my Docker hub.
Okay.
Yeah. So I pushed up a Docker image that was on Docker hub, and then when you guys typed in Docker run, if it couldn't find the image locally, it then looked up on Docker hub for something that was named with that jdkent /tut-RStudio. So then it looked up that name, and then it started downloading the layers it needed to run the image.
And what is the IP address that you're navigating to? What is that?
So the question is, what is the purpose of this IP address? So the idea is, what's nice about RStudio is that they have the GUI version that you can install, and then you have like an application that you click on, and then it opens, and you have this application. What certain technologies are heavily relying on right now is just the browser. So, So RStudio, in addition, has RStudio server, which we're basically treating our Docker image So I guess how you'd normally treat an RStudio server installation is that you have like a main computer that you install this RStudio server on, and then other people can request instances of like this RStudio server to run to run through the browser on their other machines. So what we're kind of doing is that we're making an RStudio server as a mini computer on our own computer, and then we're requesting from that mini computer to give us an instance of RStudio to run.
Okay.
And so the URL is just the connection point between that mini computer and our host machine.
Okay.
So we're able to communicate with the mini computer through this port.
I still get the same error, even with sudo.
With sudo, like it's saying the username is wrong.
It says unauthorized. Like errors comes from human.
Oh, is sock running, or is that something?
Sorry.
All right. I'm gonna pause here for a second, and I'm gonna cover. Or, no, I'm gonna pop over there, and I'm going to take a look. I think I know what the error is.
So definitely have like sudo right now.
Oh, did you log into Docker Hub on your local machine?
Like
correctly?
here.
That is, it's running. Okay. Do you want to sign out and sign back in? Just for your.
Okay.
Then in the terminal, yeah, okay, yeah, no, you can do it. And we'll see if that works.
You think? Yeah, maybe.
So I'm saying yes, if this whatever.
That still doesn't work.
It has to first on whatever packages is already done. So I'm saying whatever the commands I want to run in Python so it gets those software from the main machine.
It gets which software from the main machine?
No, what I'm saying is I have all my installed software installed in my main machine.
Mm-hmm.
This is a container.
Mm-hmm.
So this container gets all the software from my main machine. I don't have to duplicate and install inside it.
It grabs software. It still has to install software from. It doesn't install it from your main machine, so it doesn't pull software from your main machine. So it still like pulls it from wherever it needs to grab the software from, usually from the URL.
From this. Okay.
The one building the Docker container.
Yeah. Suppose I want to run Python over here.
Yeah.
Okay. So it has a lot of multiple software.
On the container, you want to run Python on the container.
Suppose I need a library, some X library,
Mm-hmm.
but that library is already there.
It is not inside the library.
Not in Docker. So can I get those libraries from the main machine into the Docker?
Like I probably wouldn't recommend that. Like you could like copy things from your main machine to a Docker container, but it would probably be better to, unless if it was specified, like unless if you shared that particular Python code like on some type of GitHub or some type of thing, it's for other people to be able to reproduce it. It would be nice to have a point to like where that code is coming from that you're copying into the Docker container. I'd say like yes, you theoretically can.
So it's better to separate.
Yeah, it's better.
But whatever you want, code, I need to put it in Docker 1. So there's another code in Docker 2 or whatever one, then you can run it, whatever.
Yeah.
It still doesn't work.
Still doesn't work. Unauthorized. Registry 1. But what does Docker run hello world do? What is the attack? Okay. Alright, that was something new. I'll come after the tutorial to help you get that worked out. Okay. Alright, and we're back. there's apparently some issues with Mac that I still have yet to figure out. So I'll get that resolved after the recording here. All right, so the next question that we wanted to cover was if we want to modify our code / data and have that accessible on our host machine. So I'm going to introduce you all to a little bit of Git, whether you want to or not, just so that we have everything be the same.
I actually had to sign out of Docker somehow.
Okay. Okay, so it works.
I just Stack Overflow.
Okay. All right, nice. So the error with the Mac apparently was having to sign out of Docker and sign back in using the terminal.
Not signing in back.
Oh,
just sign out.
Just sign out. Just signing out.
Yeah.
Okay, so don't sign in. Okay, so I guess yeah. All right. So if you're having, yeah, so I guess that's one troubleshooting step for Mac. If you log out of Docker Hub, it might help. All right. So now we're back. If to this page, which was the page that I directed you towards at the beginning, what we're going to do, this is a code repository. So what we can do with this, we can clone everything that's on here on our local machine, and we can copy everything that's on here onto our local machine. And this repository contains that same notebook that we were running on our RStudio server thing. So what we're going to do is click on this clone or download button. Then within here, we're going to click on this copy button. Then we're going to shift over to the terminal. We can exit this process. So to exit it, you can hit Control-C or Command-C. I forget if it's, no, it's probably still Control-C on a Mac. In order to exit this process, is it?
I'm going to head out, yeah.
Okay.
Can you just keep my power strip safe? The black
Yes,
one?
yeah, I will.
I'll see you tomorrow.
All right. All right, thanks for all your work. Sorry. So yeah, and this will kill the process, and if we go back here, we'll see that if I try to reload this page now to say, oh, it can't be reached, it doesn't exist anymore. So everything I did, all that hard work I hit pressing that green button went away. So with that copied, I'm going to actually remove yes, clear. I'm actually going to make this a little bit bigger. So what I'll have everyone do inside your terminal, and I guess I cross my fingers to hope that this works for everyone. We're going to type in git space clone space paste in that URL. And then that should, if it worked correctly, it should look something like the following. Did everyone get output that looks like that? You don't have Git? Or
It's okay, I downloaded it from here. I mean, I just downloaded it from my system.
I mean, yeah, that works. You can do that. I like the so I shouldn't be unfair. There is another way of installing it. You can go to actually, what did you do?
So just download. It'll go to your download section. Just download.
Oh, just download. Oh yeah, download zip. Yeah, you can download a zip file. So that makes it. I guess I hid that away from you just to make you use more programmatically. But
Trickles.
but yeah, you can just download the zip file, and that will download a nice zipped up version of this repository. I just like subtly inserting other types of lessons into here as well, since this will be the cloning method will be the way that you use if you want to then do like a more like a Git type of workflow in order to track your changes and do stuff like that.
Is the git clone the command for that then? Is that what?
Yeah, git clone is pretty much. Hope nobody is gonna crucify me over this, but I'm gonna say yeah, git clone is pretty analogous to Docker pull, where Docker pull is downloading the image from Docker Hub, and git clone is downloading the code from GitHub. We didn't use Docker pull because when we type docker run, it behind the scenes calls Docker pull for us. Okay, so that should have created a directory called tut docker rstudio. So if I type cd tut docker rstudio, ta-da, and I'm going to still look at the readme here, which is also in here. I could look at the readme in here if I wanted to type less readme. It won't show the images, but I can still look at the commands. So if you're not averse to looking at a terminal screen, this allows you to scroll through a file that is just through your terminal. I'll just do it through here though, just so it looks friendlier. And what we're going to do is now make our data and code available in the container. Our local code and data files available on the container. So we do that with the addition of this -v option. And what this tells us, tells Docker to do when we're looking at that picture of this, for this picture, where we're connecting the points between our host machine and the little mini computer that we have set up. That is what the -v is doing for us. So I'm going to, and then this PWD stands for present working directory. I think that should work on everyone's machines here. Actually, might not work on Windows. Now that I think about it, there was something else that I need to change. So you might get a weird error on Windows. Did everyone get a weird error on Windows?
Yeah.
Okay. So what I believe needs to happen is on both sides of this colon, we need to replace all the single forward slashes with double forward slashes. So it'll be // home // RStudio, and I'll show a little trick to get everything inside print working directory to have double forward slashes. So yeah, so if you're using Windows, the command shown probably shouldn't work. Any substitute // with // globally. So the command I used here, which I'm not going to go into a lot of detail, is that I am essentially printing out the present working directory, and then I'm what we would say is piping the output of that command into this what sed is short for is streamline streamline editor, I believe. But basically, what we can think of it as is a way to replace something with something else. And what it will specify here is that we want to substitute a / with 2 forward slashes. And then the G stands for globally, which means for all forward slashes that I see.
I still get an error.
It doesn't like that SED.
Sed doesn't exist on
Yeah,
Windows.
apparently not.
So if you type sed like that, you get an error, no command found.
See, my case is-
Right.
I manually replaced them and I don't think it.
It still didn't work.
It didn't work either for me.
Oh, if you manually replaced it? Oh no.
Set it into
We're gonna do some
format.
actual Docker mount
Can you just manually?
volume Windows. What was it? Can't remember why this doesn't work. So what type of error do you get? Or does it just not
It says invalid reference format.
Same.
invalid reference format?
Docker.
For some reason I thought that solution would have worked. Okay. So for that, yeah, I might just type in. I'll work with you guys in a little bit to figure that out. I'm gonna cover what ideally happens real quick, and then we'll stop and I'll put a note in the actual video for how to get it to what solution we come up with to get it to really work. So I'm just going to add to my command here. I want to have my working directory go to this home RStudio project directory, which if you remember from previously, that's where we could go just to access the regular data that was already stored on the container. So basically what we're doing here is that we're overwriting that place on the container in which that original directory inside the container was located, and we're replacing it with our own.
Can you say that again, please?
So there was so on the container itself, there was already a home RStudio project directory
That we get
That-
cloned.
that was already a part of the container from Docker Hub. So we already had that data installed. We already had like all of that notebook RMD and that Readme file. That was all already a part of the Docker image. But what we're doing here, now that we've cloned the repository on our local machine, we can think of now there's a copy of the data on our local machine, and there's a copy of the data inside the Docker image. And what the -v command does ideally is what we're, instead of that this home RStudio project directory pointing to the directory that's on that's a part of the Docker image, and then on our running Docker container instance, we're now saying I want that directory to point to this location on my local machine instead. So now when we go into that directory and change things, it will change things on our local machine. So I'm going to give a demonstration of that. So we see the 4 files located here. I'm going to go back to 120.
What was the username again for this?
RStudio was the username. And now if I hop over to the terminal here and I cd into project, and if I touch this .text or texter, whatever, doesn't matter. Now if I hit ls over here, now it exists on my local machine. So whatever changes that I make to the code here now, if I go into project and open up this notebook RMD and say, hi everyone, and if I save that, then if I look at the beginning of the notebook on my local machine, I can see that that change has now been propagated from what was on the Docker container onto my local machine.
And so those are permanent changes then that you're making. These aren't.
Yeah, so these are permanent changes, but I guess it's permanent insofar as what Git allows you to do. So if I wanted to get rid of all those changes with Git, this is now a little bit of a side lesson. I could do git reset head hard. And now if I look at the title of my R notebook, then that hi everyone was gotten rid of. So this is kind of the combination of using Docker and GitHub to have like full control over your software environment and your code in order to make your workflow as containerized as possible.
Is there a way where you could like link them and have that, like those files available in your container, and then like decouple them so that you can make changes that you're not sure you want to like add to your Git repo yet?
Yeah, so the question was, can we make it so that the Docker container contains, or that the Docker image contains these files by default, but we can also decouple the Docker image and the files that are shipped with the Docker image, if I got it correctly.
Yeah.
Then the answer is yes, and that is kind of what we just did.
Okay.
Where let's take a look at we can take a look at the Docker file, and this is the recipe file that we made. So for me, it's a very short recipe file. Since a lot of people have been using Docker and have been making images that have a lot of stuff already installed. So a lot of the time, you can find something that somebody else has already made and just make your small additions on top of that. And what this copy command is doing is taking everything that's inside this current directory, which is the code, the data, and the code and the data, and copying it into the Docker image as it's building. So that's for the first time the first time you build it, and for like every time that you want to recreate the Docker image, you can set that to be done automatically with Docker Hub. So I guess this is a little bit outside the scope, but you can connect your GitHub repository, which contains the code, and your Docker Hub repository, which will contain the image. And that every time that you can set up Docker Hub to listen to GitHub, so that every time that you push a change in your GitHub repository, in your Git repository up to GitHub, Docker Hub will hear that, and it will build a new Docker image based on the changes in your in your GitHub repository.
And does that change the recipe?
So it will not change. This recipe will remain the same, but what actually happens for the copy command will be different.
Okay.
Because it's just copying whatever's in the current directory. So if you change what's in the current directory, then the copy command will be copying different things into the Docker image.
How can you implement that in the recipe?
Implement what?
That
Sorry.
it hears, like listens to GitHub?
Yeah. So you don't implement that. You don't implement that in the recipe.
Oh, that would be perfect.
That is, you have to hop over to Docker Hub. And if you're logged into your account, and then this is my RStudio thing. Okay, so this is a little bit outside the tutorial, but I'll just show you quickly. No, that's not what I wanted. I want to go into webhooks. No, that wasn't webhooks. It was builds. Yeah, I had to configure automated builds. Is what I had set up on here. So when I go through here, I go to automated builds, and this is all just stuff that you click. So it's all through this clickable interface. And I connected my Docker Hub account to my GitHub account, and then I specifically created this Docker Hub repository to build from this GitHub repository. So this links back to my GitHub repository. So these are now connected to each other, and every time that I push to master, it'll recreate the image for me. And then to your point on decoupling the code and data that are on the image to locally, that is why we'd want to use the -v command. So let's say I made some changes. So I cloned the repository, and now it's I am inside the repository, which I am. Let that exit. I'm inside the repository, and I made some changes to the notebook. Or I guess I want to make some changes to the notebook in my development environment. So I want to make the notebook that we see here is the one that's on my host machine. It's the one that I have the most physical access to, and I want to be able to access this file within the Docker image. So that is what this mount command does for us. It's saying I want to take whatever is typically, or what was in this directory, which is where we copied the code originally. I want you to overwrite it with this directory that's right here, which is my code directory that's on my local machine.
But so any changes that you're making to the files within the container will or will not be like written to the cloned repository?
They will, with the -v command, they will be written to anything that I change inside the container. So I guess this will boop. So restart. So again, so now this is the same directory as is here.
Because you just overrode it again, right?
Yeah, so now it's overwritten. So now any changes that I make in here will be permanent in terms of like as soon as I exit the container, the changes will not disappear.
And if you
But
would,
that's not the same. That's not really decoupled then, right? They're still like what I'm imagining is a scenario where you might like clone your GitHub repository and then want to experiment with some of your scripts or something in the container, and then if you're like, oh, that didn't work, that broke everything, let me, not push this to my GitHub.
Yeah.
How it seems to me like this is keeping them coupled so that you couldn't really do that as efficiently.
So like you want to see, so the question is you want to be able to break things in this environment and not have it impact like your your whatever you have already committed.
Yeah, so is there
Yeah.
a way to host like some kind of duplicate of the repository without them being linked in that way to where anything you change in the container is changing the local directory?
So what you have, I think this is more of a now becoming more of a Git question. So what you can do with Git, so right now I'm on the master branch. So if I do Git branch, I'm on the master branch. Let's say if I wanted to test a bunch of changes but keep my master where it's at,
Yeah.
then I would do the git checkout b test branch.
Okay.
And now it'll say what's modified, but I'll still need to like take a snapshot in order to of the repository where it's at in order for this to still count as part of the test branch. So I'm not going to cover this, but I'm taking a snapshot of the repository where it is right now.
Right.
Add hi. And now if I do head, so this is just looking at the beginning of the file. I'll see hi everyone. But now if I do git checkout master, now the hi everyone is gone. So if you wanted to do like changes and you just wanted to do experimental changes,
Yeah.
and you just wanted to see what kept going on, and if you broke everything, you'll have a way to just nuke it. That is what a git branch is the perfect solution for.
Okay. So no, there's not really a way to actually like decouple the
With Docker,
from the...
I wonder, but I mean, if you pull it on your local machine, then it's basically decoupled. I mean, what he did
Yeah.
with the -v command, it's basically decoupling it, right? You can always pull again from GitHub exactly the version you just nuked.
Yeah.
Hmm?
Yeah, that's true.
So I feel like that's pretty decoupled, right? I don't know.
Yeah, but the changes that you're making in the container are still like obviously making changes to your local files that you pulled from GitHub, right? So that was just
Yeah.
my question, is if you can have it in some kind of I don't know, secondary kind of like some
Yeah.
other environment that is isolated from the like
Yeah.
local drive. Which
but
I
you
guess
still
this
might want to
would be-
record those changes even though it's isolated. Yeah. Then I think
Maybe
I think the Git solution was like the Git branches. I mean that's what that sounds like to me, is like the
Okay,
solution is like to use a different Git branch to test out different scenarios, and then you can still run you still overwrite the place in which you put that new branch inside the Docker that's running inside the Docker container. But then you're able to have all those changes and break everything and still have like your master branch that works.
Right.
If you would not
Fair
do
enough.
the -v command, right? Then
Mhm.
as soon as you close your notebook or as soon as you like save the stuff within your notebook, it would by default push it to GitHub. Docker Hub.
So the question is, if I change things in the container as I'm running it, then exit, what happens to those changes? Those changes are thrown away.
Okay, so there it's thrown away. And how can I make that it automatically pushes to Docker Hub?
So to have automatic pushes to Docker Hub, I think using the -v to connect it to a local clone version with your Git repository that has all the code and stuff, code and data that are associated with it, and then push the Git repository, and then have your Docker Hub connected to your GitHub. So it's a kind of a big circle.
Okay.
But that is the workflow that I use for this one, and I think, I mean, it sounds like a lot, but I mean, once you get it set up, it doesn't feel like a lot.
Okay.
But I think that would be the answer to that. All right, were there additional questions? Otherwise, because you guys can't actually do it because I haven't figured out that error yet. So I think I might stop the recording now and actually get you guys functional. All right. Thank you for listening.